Nitrogen and phosphorus waste in water. Maya Johnson, Katie Lind, Kate McMillan, and Robert Reeder. Nitrogen and phosphorus waste is also known as nutrient pollution, and nutrient pollutions can directly affect water, which brings wastewater into play. The majority of homes and businesses send their water directly to a wastewater treatment plant, and each of these treatment plants have a set standard for the water to be cleaned. However, a set standard does not mean or equal zero pollutants, and this is where nitrogen and phosphorus waste come into play. Some of these plants are able to remove more nitrogen and phosphorus waste from the discharged water, depending on the equipment. However, the better the plant and the more advanced, the more expensive. Due to this, most plant systems are not enhanced and still use conventional treatment methods because upgrades are too pricey. Nitrogen and phosphorus waste into water come from a multitude of sources: agriculture, stormwater, wastewater, and in around the house. With agriculture, nitrogen and phosphorus waste can be found in animal manure and chemical fertilizers, and both of these are used to grow crops. And if the animal manure and chemical fertilizers are not fully utilized in plants, the nitrogen and phosphorus waste can be lost in farm fields and impact downstream water quality. As for stormwater, precipitation contains the nitrogen and phosphorus waste. And when the precipitation falls on hard surfaces such as rooftops, sidewalks, and roads, it can get carried into local waterways. And as stated, for wastewater, most wastewater treatment plants do not operate properly and remove enough of the waste before discharging into waterways. And finally, as for in and around the house, fertilizers, yard and pet waste, and certain soaps and detergents all contain nitrogen and phosphorus, which can get into wastewater and or into the air if not properly used or disposed. Also, with houses, depending on the type of landscaping or hard surfaces, this can also increase the runoff of nitrogen and phosphorus waste during wet weather.
Nutrients such as nitrogen and phosphorus pollution is called eutrophication. The National Oceanic and Atmospheric Administration says that 65% of the estuaries and coastal waters in the contiguous U.S. has been damaged by excessive nutrient inputs. This is a very real and current issue we face in the world today. Within the past 50 years, eutrophication has emerged as one of the leading causes of water quality impairment. Nitrogen and phosphorus pollution can affect you whether you realize it or not. It destroys lakes and water resources many people rely on, and limits available water when drinking water is a global scarcity already. Algae blooms devastate rivers and coasts around the world. Even global trade and food securities can be affected by contaminated waters and disrupted ecosystems. Nitrogen and phosphorus pollution already impacts the world around us, and soon it could reach you too.
Activation for activated sludge. So basically we do a test called the biochemical oxygen demand test, or the BOD test. The activated sludge process uses a suspended growth of organisms to remove BOD, or suspended solids. We do not want BOD in our water. There are factors within these calculations: the temperature, the return rates, the amount of oxygen available, the amount of organic matter available, the pH of the water, waste rates, aeration time, and wastewater toxicity. So with these tests, you can pick the amount of the sample and plug it in to see how well the BOD is removed. So for the first equation, you use it when there's enough microbes in the solution, so you don't need a seed correction. This equation is you subtract the initial demanded oxygen from the final demanded oxygen, and you multiply it by the 300 milliliters. The 300 milliliters used in both equations is standard, normally because a BOD bottle is 300 milliliters, and then you divide it all by the milliliters of the sample. The next equation is used when you need a seed correction, or when there are harmful microbes or not enough in the solution. This one, you would subtract the demanded oxygen, the initial from the final, and then include the seed correction in the subtraction. You would then multiply it by the 300 milliliters and divide it by the milliliters of the sample. So here's why we need activated sludge. It requires less maintenance than alternatives. Relatively, the solution is really simple, which helps save time and money. It can reseed on its own by adding good bacteria, so you won't need as many seed corrections. Overall, it is a cheaper and more economic alternative. Thank you.